Hi folks, Harper Dada again here today. Let's try valid parenthesis, Leetcode 20. It has been characterized as easy, and I guess let's hope it really it lives up to its expectations. So, the problem description is given a string containing just the characters, left bracket, right bracket, left parenthesis, right parenthesis, brackets, square brackets, braces, all these things. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of bracket. I see. Open brackets must be closed in the correct order. So that's all looking good. It's saying the empty string is also considered valid. So the example is if you have this, then it is true, obviously, because there is a matching parenthesis here. Same thing here, everything is matching, so it's all looking good. This is false because you have a left parenthesis, but then you have a bracket here on the right. Similarly here, you see there's no match for the, now for example, you see that it has the number of characters that we need, the required number of characters we need, but the order is wrong because ideally this guy should have been before here, like at the second position or the first position, 0 first, and this guy should have been here, so that is why it is false. This one is true because not only you have the required number of characters, the count of the characters, but the order is important too. So how can we so the order is correct here as well. So how can we go ahead and take a shot at this problem? Let's look at the hints. An interesting property about a valid parenthesis expression is that a sub-expression of a valid expression should also be a valid expression. Not every sub-expression, for example, is valid expression. So now he's saying that a sub-expression of a valid expression should also be a valid expression. Not every sub-expression. For example, and then he says this is valid expression, and within that this one is a valid sub-expression, and this is also a valid sub-expression. And then he is saying, can we exploit this recursive structure somehow? I wonder, does that imply we have to use recursion? That doesn't sound to be the case. So what we do here is that if you recursively try to see if we are having the right expression, so since the order is important, maybe we can use some kind of a stack, and the stack is in Python is implemented using, can be implemented using lists. So say stack equal to a empty list, and as you know, when you append, basically use these two operators like append and pop, append and pop. So maybe we should write a comment here, and that let us use the lists append and pop operators to simulate a stack. So that's our stack. Now what is the next thing we need to do is just start walking the input string for C in S. That's the beauty of Python, such beautifully, elegantly expressed. You don't have to say s.char array or things like that. So this is direct C from the, as they say, it came from the mouth of the gods, but I guess the gods in this case were the programmers who actually created this, or the designers of the Python language. But in any case, before I digress on my mythological adventures, let's continue with the coding. So for C in S, what do we need to do? Say if C in, let us say it is in one of these. So we start by taking into consideration the opening parenthesis. And so here we are. So for if C in any of these, then we basically push it on the stack. And that is by saying the stack.append C. So what our approach can be is that we can keep pushing these opening parentheses, open brackets, and then as we walk, if we ever see a character which is closing parenthesis, like imagine here, just take the very simple case of this one. If you see that, then you would see that if we hit, so when we are here, we just append, and then when we go to the next character, we should see what is on the stack. And if we have a matching, meaning the corresponding bracket on the stack, then we are in good shape. So every time you see a closing parenthesis, closing bracket, you pop something from the stack and see if there is a match. And if there is a match, we are in good shape. Like for example, here the same thing. You append, you pop, there is a match. You append, you pop, there is a match. You append, you pop, there is a match. And here, let's say you append, you pop, there is a match. You pop again, and then you see that there's a match. Yes, there's a match. So this is good. So that is what we should be doing. So let us do this now. So if C in this, else we say else if, which is Python's way of saying else, if elif, oh no, not here, if else C in, if C equal to, I guess. So now if imagine we hit a closing bracket, and imagine that our stack is not empty. And how do you say that in Python? See, because see, when you hit something like this, your stack better be not empty, because if the stack is empty, we can return false right away. So the stack there has to be something on the stack to match this closing parenthesis. So that's why we have to say end stack. And then end stack, and if the character on the stack, which is Python, how do we get that without actually doing the real pop? This is the last thing that we put on the stack. You can get by stack -1, or basically the list. When you use -1 on a list in Python, you get the last thing that was put in, appended, and that is equal to, now what do you think we should do here? What are we looking for? So when we have this, then the top of the stack better be having its corresponding opening parenthesis. So that's where a little confusion can come in. So it has to be the complement of that, not what you have right now. So you are in your walk, this for loop, you have you are actually saying a closing parenthesis, but then now when you pop, you want to see the opening parenthesis, and that should be good. And then we can, if that is the case, then we are okay. We can simply say stack.pop. And as you know, in Python, when you say pop, if you did a pop 0, then it would actually behave like a queue, but you want a stack, so you want to do stack.pop. So now the same thing let's do for the other brackets. So basically all we did is we say, okay, fine, everything is good, let's just pop it out. We don't need that anymore. We are golden at this point. up to this point. Now, else let's take this case. So no, so this is other way around. So this is we hit the closing, and now we want to make sure that the popped character. Ideally, we had set popped char equal to stack dot pop. So here this popped char is equal to the opening parenthesis. And how do we do that? That is here. Same thing we do the for the brackets. So up to this point, it's all looking good. So this is whenever you have the closing. So you're saying I hit the closing parenthesis or bracket in my walk on the for loop, and as I hit that, I did a pop on the stack and looking for the corresponding open parenthesis. And if that is the case, then everything is fine. Otherwise, we have a problem. So if none of these cases are hit, because what could happen is that imagine you got a closing parenthesis but the stack is empty. How can the stack be empty? Because you see, only thing we ever put on the stack is the opening parenthesis. So you may have some strings. I'll come to that later. The failure cases where we will see how this code will behave. So here we can say return false. That is one case of return false. And then if we come to the, so this false will take care of the cases when, so that means none of these other cases were hit, in the sense either we had a closing parenthesis, the stack was empty, we had a closing parenthesis, stack was not empty, but popped character wasn't the opening parenthesis of the same type, we have a problem. So if any of these conditions fail, we come here and we say else return false. Now if we never came to else, then what else could happen? Then we just need to make sure that we should see. Now imagine the case where you have many opening parentheses without having their corresponding parenthesis on the closing side. So you would have popped everything, but then you would have probably still bunch of opening parentheses lying on the stack, and the stack will not be empty, and that's not a valid parenthesis. So we have to in the end just see if a stack is empty, return stack is empty or not. We need to see if a stack is empty, we are okay. If a stack is not empty, we have to return false. So how can we do that in Python? So if a stack is empty, we are okay. So if that is not a stack, that means we return true if stack is empty, because stack empty will evaluate to in Python just by saying not a stack. Basically it's a list. What is the stack here? It's just a list for all. If not list and the list is empty, you return true. So that is what it is. So let's try to run this code. Okay, so it has been accepted, and the test case was is saying false actually. So actually we have to have the whatever our friend was giving here. So let's try this very simple case, and it is true and it's true. But now let us do one thing just to see where we hit. So now let's see why this case is needed here, else return false. So if you come here and let's just say this, like let's put bunch of closing parentheses and see what happens. False, false. So now let's do one thing, let's put print our stack every time we enter here for C. So let's keep seeing what a stack is looking like right now. Okay, so we will see how the stack is. Okay, run code. So as you can see, what happened is that we started with the empty list, then we appended the opening parenthesis, then we here I guess we emptied, popped out the right thing, everything was looking good. But then, so the stack I was printing, and then we come back here, and then we say for C in S we are basically done, there are no more. We already returned, actually this one was printed at the point where did we print that? So we basically, first time around we hit the opening, we added that here in this line here, for if C in opening, we that was ended. And as we, so we hit that case, so there's none, so that means if C, so that one was taken care of. We went back, and that's why we saw that that is the case here, stack has. Then we found the in the second character was the closing parenthesis, so then we would have hit this guy here, and we didn't return again. Third time around we basically see that the stack is empty, and then we say return false. So if C wasn't this and this condition didn't match, so I think it probably hit here, not, it didn't return false from here, it returned false from here. Let's see that. So let's do a print, and let's call it returning false here. So returning false here. So let's see the run code. That's absolutely the case, because you see first time around we hit this case, second time around we hit this case. Now we went back, stack was empty, so basically we ran out of the characters. So I mean we didn't run out of the characters, but we are still walking, because remember our string is this here, don't confuse with what they had here. We have three extra closing parentheses, so we are still walking. So when the third character we walk here, we hit none of these cases, neither open. Now this you think it would have been correct, but then what? Stack is empty. We have popped everything out of the stack, because you remember we only put opening parenthesis on the stack. That is probably the hint in this case, in this problem. You put only open parenthesis on the stack, and the closing is just to, so in a way stack here is nothing but kind of a housekeeping, where you keep putting the opening parenthesis every time you see one, and as you're walking, and every time you hit a closing parenthesis, you pop things from the stack. So the things on the stack are only opening parenthesis, never the closing. So when we hit the third character, we none of these cases were true, because even though you would see this is the closing parenthesis, but stack is empty, so we didn't hit this case. So ultimately we hit this case here. We say print returning false here. So that's why you hit this case. Now take another example. Let's do another test case where we have bunch of opening parentheses without having the closing parenthesis. So now we have, I guess, more opening parentheses than the closing parentheses, and let's see what happens. So now you see what happens. We return false, because you know what happened, even though all the closing parenthesis consumed all the opening parentheses, but we still had not all the opening parentheses, but all the corresponding open parentheses, but we still had extra open parentheses. So that's why we return false in this case, not from here but here, because we in the end, when the whole for loop, when we are done walking this string, we say return true if stack is empty. So stack wasn't empty here, and that's why we return false here, and maybe